All right. Finished linked list yesterday. Let's do all the remaining tree problems I have never done before. What's going on here? Why did I get logged out? One sec. Okay. So construct a quad tree. You're given n by n grid with zeros and ones. We want to represent the grid with a quad tree. Return the root of the quad tree representing the grid. A quad tree is a data structure in which when each internal has exactly 4 children. Besides, each node has 2 attributes: the value okay, so if it's a leaf, true if it is a leaf, and false if the node has 4 children. Okay, so we have node top left, top right, bottom left, bottom right. We can construct a quad tree from a 2-dimensional area using the following steps. If the current grid has the same value, set is leaf true, and set val to the value of the grid, and set the 4 children to null and stop. Okay. And set value to any value, and divide the current grid into 4 subsections as shown in this photo. Recurse into each recurse for each of the children with the proper subgrid. If you want to know more about the quad tree, okay, this seems fucking insane. Okay, let's see a simple example. We have the root here. So is leaf? No. Notice that 0 represents 1 represents the photo, represents the quad tree. Okay. Oh my god. Okay, so what is happening here? Oh my god, this is kind of crazy. Okay, so the value is 1. I don't really get why that's 1, but it has all the values. 0, 1. It went like this. Okay. We have this, this, this. Or it went like this, 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 this. Well, that doesn't. Oh, wait, we can do like. The main issue is what? This quad tree is weird. Notice that it represents false and 1 represents true in the photo representing the quad tree. You don't need to read this section for solving the problem. It's only true if you want to understand the output format here. So the current grid has different values. Set is leaf to false, and set val to any val, and divide the current into 4 subgrids as shown. Oh, okay. So this is that, and then the top level is this, the bottom level is this, and then this is the root. So root. So root. Okay, never mind. Actually, we have this here. Bum, 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 bum. I don't know. It looks like it's supposed to be like this, but I don't know. It doesn't look. This kind of looks weird. This is kind of confusing. Let me try. Let me see if I can understand the small one. So we have 0, 1, 1, 0, right? The exponential. So we have that leaf 1 value 0, leaf 1 value 1. So 0, 1, 1, 0. 0, 1, 1, 0. Makes sense. Okay. What is this? It's kind of confused. Is this like a DFS? Divide conquer. I guess kind of a DFS. I could see a DFS. So basically, we're just trying to like break them up into quadrants. Like, okay, so this thing here is a root. Maybe that's the entire grid. And then we break the top left. Then we do top right. Yeah, that's top right. Bottom left, bottom right. But the top right has more subs. So we have this, 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 and this. Well, this one is this one here. Okay, so, okay. It's definitely some DFS thing here. So, okay, so we have DFS takes in the size of the grid, because I think we can break this up into like by half. So this is n divided by 2, n divided by whatever you have. Keep going, 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 going. And I need to check, and then I'm grouping them together by, so this is the whole tree. This is top left, top right, bottom left, bottom right. Takes the size of the grid. Takes the size of the grid. Okay, GG's. Okay. And then I probably need to return like some nodes. I probably make a node class. Well, actually, we already have it. Never mind. So we probably, and then we need to check if all the same. If all the values in the subgrid are the same, I think we could just loop through it. Does this constraint? Constraint doesn't look terrible, but okay. Check if all the values are the same. If they're the same, then we can return early there, right? Because that would be we return up and we return one node here. I see now. Okay, if it can be compartmentalized, I guess, then you keep breaking it up, you know. But yeah, okay, now I see the tree now. Okay, if the same. Takes the size of the grid, check if the values in the subgrid are the same. If the same, return the current node. If not, recurse down and break it down. Break into 4 subsections. So I got it now. I think this is pretty easy. So we'll do this. Def DFS. We'll do n. We'll do I guess we just take the size of the grid for now. Size of the grid. And okay, so we'll do is same. We'll say false, or if that true, and we'll do forever I in range of n, forever j in range of n, grid of I, j, if grid of this does not equal grid of shit. Do I start one more, I guess? So I need to do like the previous, like 0, 0. Okay, so, okay. I plus 1, j plus 1. Yeah. Then is same, false, break. Wait, I should probably have row column. We're gonna start at the top, 0, 0, and then break it up into, so this is size, for example, this is gonna be size 4 divided by 2 is gonna be obviously 2. And we would basically do an offset of that. But so it actually puts themselves in their own quadrants, right? Like here, the size of this is 1, 2, 3, 4, 5, 6, 7, 8, about 64. So if we divide by 2, right? Or divide by 2, that'll be what is it? 64 divided by 2. I think it's 32. We do a plus 32. It'll be in their own quadrants. So that'd be nice. So first off, if it's the if same, then we can just return the node of grid of I. Not ij, row column, and everything else no, because that'll be a loop. That's it. We bubble up here. That's the base condition. Now, and we'll just decrement, right? Then we'll do top left, which is node, with the new n and, oh, not node, DFS, with the new n and the new r. So it'll be RC, but okay, top left is going to be like top left is going to be, what should my adjustment be? Like, I think I should leave this here. Top, then top right. I want my row to move, so we'll do plus n here. Then bottom. Okay, so bottom right, that's gonna be down, so we move the column. No, we move the row, so row plus n. I got this from top right. It should have been C plus n, right? And we leave C. Bottom right equals DFS. and r plus n. Wait, okay, so bottom right, that is, we want to move from, we want to basically do these 4 quadrants. So here, this is here. So like, to get here, I need to move both of them. So r plus n, c plus n. Yeah, so I need to move 2 here, 2 down. Yeah. Here, I just need to move 2 down. Top right, I just need to move 2 right. Here, 2 down. Okay, that makes sense. Now, we recursively build this out. So we'll first say the grid of our RC, and we'll do top left, top right, bottom right, bottom left, bottom right. Then we'll do DFS at length of grid at 0, 0. I think that works. You know, okay, I'm just gonna do J plus 1. Think that should work? Out of range. Can I do I plus 1 then? Because I need to check, okay, in the subgrid, right? I want to basically check basically at a time. I want to check basically like if all the numbers are the same. I can just do that by I'll do this instead. Let's do majority equals grid of RC if grid of IJ does not equal majority, then is same equals false, and break out. Is same equals false. Or true. Invalid. Top left, top right. Bottom left, bottom right. Uh-oh. No, no, no. Did I mess something up? Bottom left, bottom right. Bottom left is basically I just want to move this down, but keep the current C. Wait, hold on. Top left is I want to move. Yeah, I just want to stay here. Yeah, that makes sense. Wait, okay, I forgot about the offset. Hold on. I should say R plus I, R plus J, C plus J, because okay, that's because I need to check the right. That should be it. And then okay, I think hold on. Oh my god, I forgot one more attribute. This should be true. And this should be false. How about that? Okay, there you go. Alright, see you guys tomorrow.